look at potential energy functions. So whenever I have a potential energy function, the first requirement is I need a conservative force. So we already talked about the equation for potential energy for springs and gravitational situations. So now we're going to do kind of made up forces just for us to work with. So the number one requirement whenever you have a potential energy function is we need this restoring aspect. And so you'll notice that like if it stretches it away from equilibrium, the spring pulls it back, meaning the displacement and the force have to be in opposite directions. And so that's where we get this negative sign from. Now, this negative sign is also the number one thing students forget when they go back and forth between a potential energy function and a force function. So keep that in mind. So what we're going to do first is a quick little example here of 7.30. In an experiment, one of the forces exerted on a proton is, and I have a negative 12x squared I hat. All right. How much work does the force do on the proton as it moves along a straight line path from the point 0.10 to a point 0.1, comma 0.4? So I drew it over here so it makes a little more sense. So A is going from my 0.10 up to 0.1, 0.4. Now you'll notice the direction of the displacement is up, but yet my force is directed this way. So those are perpendicular, yes? So perpendicular, so for part A, the work done is 0 joules because the force is perpendicular to the displacement. Drop my marker. All right, now let's do part B and C. So part B says, how about along a straight line path from the 0.10 point to 0.30? Okay, so we're going this direction. Now notice our displacement is this way and our force is pointing this way, so we should end up with a negative work, yes. Now, because our force is not a constant, it's a variable, we will need to integrate to find this work. So our work is going to be the integral from 0.1 to 0.3 of negative 12x squared dx, noting that my I hat one needs to be integrated in my x direction. All right. When I type this in my calculator, I end up with a negative, what was it, negative 0.104 joules. So we lose energy, it's removing energy. And so that means we're getting further away from that equilibrium point. Our equilibrium point is going to be located at 0 because that's where our force is 0 at, okay? And then we need to find part C. Along a straight line path from the point 0.30 to the point 0.10. So now we're going to be heading backwards. Okay, so all I need to do then is find the work on my way back. So from 0.3 to 0.1 of negative 12x squared dx. And I plug that in my Math 9 on my calculator. I get a positive 0.104 joules. Now noting here that I go over and I come back, so I end in the same spot, my net work will be 0. Also noting that my I hat direction is only dependent on x, we do have a conservative force. And so the next part says, is this force conservative? And explain, yes. So I can do the box test if I wanted to. I could go up, over, back, down and show that. Or I can do my little quick trick where I check to make sure that the I hat direction is only dependent on x, the j hat direction is only dependent on y. And then it says, if the force is conservative, what is the potential energy function for it? Let u equal 0 at x equals 0. So in other words, they're giving me my constant of integration. They're giving me my initial condition there. So in order to find a potential energy function, I'm going to need to move the negative over, move the dx over, and integrate. So my potential energy function is going to be the integral of the negative force function, negative 12x squared dx. And we're going to do an indefinite integral because we want a potential energy function. Okay, so now I have 12x cubed divided by 3, and that'll be plus c equals u. And so my potential energy function here is 4 x cubed, and they said the potential energy at x equals 0 is 0, so that means my C is 0. So I do have my potential energy function. This is measured in joules with x in meters. Okay, there we go. And that is our problem, but remember to put that negative sign in there. Do not lose track of that. Okay, so there we have it.